Howdy folks, welcome back to another video. This should be a relatively short one. It's 2 days after Christmas. I hope you all had a great holiday and Santa was very good to you. Being that I am a stubborn son of a gun, I cannot let this misbehaving tachometer go any longer. I believe I have come up with a solution. I still do not know why it's misbehaving, but the part of the solution is going to be part of what we're going to use to hopefully figure out why it's misbehaving. This will pretty much explain everything. I'm really just showing you this because in case you needed to do some sort of diagnostics like this, there is a way to do it where you don't have to have expensive test equipment and you can kind of do a trial and error thing and just kind of use good practice electrical diagnostics as far as that goes, plus a good wiring diagram, and you can figure out a lot of this stuff. So we'll start with the fact that this was the instrument that I had been missing for quite a long time. As you recall, if you 2.5 of you that watched the video, this is the replacement instrument package I got from Richard up in Northeast Florida. Thanks again, Richard. Cannibalized and pulled parts from to make this guy work 100%. In particular, that center display there, the LCD display. That was my main concern. And then I had to bodge wire it in that last video. In addition to this nightmare, this ribbon cable deal that I bodge wired up, this is the original module that the service manual calls a speedometer and tachometer computer. Now you may think that Honda took a little bit of license with the term computer, quote unquote, but as we find out later on, it really is a computer, and I'll show you how we do that. So this is the one that mounts on the back side behind the tachometer on this housing, and this again is the replacement tachometer instrument itself that came out of this one here. Now, as you recall, I took the motor out of this one and I put the motor in that instrument there, the one I was showing you before, the one that's on the bike, and it didn't solve anything. Likewise, I took this out and the other one that drives the LCD cluster in the center out of this display here, fixed the clock and other functions, but it didn't do anything as far as repairing the misbehaving tachometer. So this is the original one that came out of the display I have, the original motor underneath here, and again this is the original part here. So the only thing that's not original up here on the bench is the instrument itself, the face and the little gearbox thing on the back of it. And there's the original motor, like I said. And I put that back on this morning. Now the first thing I did was I just set it up and used my 12-volt power supply and started probing this to see what it would do. Because I'm trying to learn what this thing does and how it works. I couldn't get it to do anything. So I said, I wonder if there's a way we can set up a test bench. So what this test bench setup is doing is essentially giving us a comparison. We are comparing one instrument to the other to see if one works versus the other. It doesn't tell us what's wrong with the bad one. It just tells us that one works, and at least we can solve the problem with that. And if we take the one that's misbehaving afterwards and put it in the same exact configuration, we may be able to actually figure out what's malfunctioning in it. So what this does, it rules out that we have a signal input issue. In other words, a signal from the CDI that's triggering that computer, quote unquote, to do what it's supposed to do with a gauge. And this particular gauge is the replacement gauge. So we're essentially testing whether or not the replacement gauge works in the exact same setup as opposed to the gauge that's on the bike, the original gauge that is currently misbehaving. So there is another way to do this, of course, is just take the replacement tachometer and install the damn thing into the cluster. But that's a lot of work to take that off, take it apart, put that instrument in, that gauge in, the tachometer replacement, and then see if it works. And if it doesn't work, then it's all waste and we still don't know the answer. So if we do it externally with a test bench, we can verify that we do have a good working tachometer replacement and then go ahead and go do that work. So that's the whole reason for doing it this way. Okay, so the first thing I did yesterday was I pulled the tank off, disconnected the 1 3 coil, the yellow wire that goes to the 1 3 coil, because it tees off between the IC igniter, comes up to the yellow wire up onto this plug here. I wanted to test the continuity of that wire. If it's hooked up to the coil, I couldn't do that because it would have some sort of a ground path even through the primary side of the coil. So once I did that, I checked the wire. The wire's perfectly fine, as I suspected. Right now I just have the tank laid back in place, so I have a fuel source, and then came up here and said it's got to have something to do with what's up in the display. So we're tapped into the yellow wire that comes off of that ignition impulse. I believe that is terminal number 9, 8 or 9, I can't remember which. And then we're running up to the test bench here. As I looked at my wiring diagram first, this is where these things really come into play. If you're not familiar with wiring diagrams or they intimidate you, just start studying on them and you'll figure it out, and it's something that's very, very helpful. The first thing I wanted to do was figure out what the power and ground wires were that fires this whole damn thing up, or at least this side of it. This is the shorter plug. This is the one that I just pointed at that has the pins in it that powers up pretty much the tachometer, the speedo, and that little computer. And then the bigger plug is for the LCD display and so forth, but there is only one power and one ground that comes into this. Through a combination of this wiring diagram and doing some probing with the digital multimeter, I figured out that brown with a black, which is your power, you can see it comes right off of a fuse number 5 in this case, tees off and goes to a bunch of places, but it does go directly into the display, so it's got to be our power for the display, the whole display unit, which is what this represents here. And usually Honda uses a green wire or solid green wire for ground. Well, in this case, it's a green with a black. Now, I looked around on this drawing, and the only place that it references a ground is way up over here, but that is a ground symbol. So this green with a black is tied into the solid green right here, so I know that that is a ground wire. So I came over here to the plug, disconnected, verified those, my power and my ground, then came over here and extrapolated that to the appropriate pins. So it's the second pin in, I believe that's, I don't remember the pin number, it doesn't matter. The second one in on the top, then you have the little space here for the clip, and then the next one on top is the ground. So this is power and that's ground. The yellow one, actual trigger wire for that signal, it's this one right in there. That is the pin that goes to this yellow wire that goes up into the module. Plug this little ribbon cable in, which was also destroyed like bodge wire I did on this side over here. Off camera I did all this one too. I wanted to see if I could, and I did. Hooked it up to power on the power supply, and it fired up. I hear the you know, the speedometer doing its self-test thing, whatever the hell that is. And I knew that I was getting power up here. What I need now, of course, is the signal, which is where that yellow wire came off of over here. So I'll set you up on the stand now that you understand how I kind of figured out what we're doing with, how I'm going to do this rather, and I'll show you the result. We'll also fire up the oscilloscope on that so you can see the signal. It's just for reference. I did not use the oscilloscope to diagnose this. It's just to show you, it's a visual representation of the signal that this thing is interpreting to generate, I got gas, to generate the appropriate RPM on this instrument right here. Okay, I got power, ground, and that signal for the oscilloscope hooked up, and the trigger hooked up, of course. We'll go ahead and turn on the power supply, and when you see it here, just fire up, and we'll go to 12 volts. 12.5 is fine, and then we'll go ahead and start the bike, and then once we start it up, you'll see the result. Okay, so that's where this one's reading, around 1,000 RPM, close to it, which is where it should be. And if I bring you over to this one, 400 to 500, about 450 low. There's your signal on the oscilloscope as far as what it's picking up. That's only for reference. So what this module is seeing is that signal, and then it's calculating it out to do what it needs to do on this tachometer. Now, I want to show you how this thing works because this is really important. You see how the worm gear is just kind of almost like twitching? Not the easiest thing to film. This is a lot better. I can keep it still this way. You see how it's just wiggling back and forth, back and forth. So that's all this does. And of course, when you rev it, it goes up and then it'll maintain, if you were at a set RPM, the exact same way. Otherwise, it just turns it till it gets to the point where it says, okay, that's the RPM I'm at, references it on the instrument itself, and then comes back down. Or in the case where you shut it off, it just drops back down, which I'm assuming is that little clock spring in there doing that. You know, because the clock spring kind of rewinds it, if you will. But that's all that does. It just kind of does this. Something going on in there inside this module that's pulsing it. So it's pulsing it to maintain it and keep it into the RPM that's supposed to be at. Now I'm kind of surprised that with that little bit of movement, it doesn't kind of get jerky on the display here. And I'm thinking maybe that spring has something to do with that. It's kind of like a damper. Maybe that's really the main function of that is to be a damper for that. Because otherwise the thing would be kind of jerking around even with that little bit of movement. So that's all this thing does. It's pretty cool. And you can see it reads properly as far as the RPM goes. I don't know why, but we're going to find out, because once I put this one in there off camera, we're going to come back with the one that's in there now and do the same exact test, and then see if we can maybe manipulate it, or maybe just put a little oil down a little shaft or something, I don't know, and figure out what the hell's going on with it. But I thought this worked out great, and I'm really looking forward to this thing actually reading properly. I got to do a little restoration magic on this device itself. You saw a little dirt in that worm gear. We'll clean all that out. And then I'll bring you back when we're ready to do the reverse test. Okay, we're mostly back together. Well, we're pretty much all back together on the front. I don't need to tap in up there anymore for a signal. I'll go into that here in a second, but I want to show you this. So everything works, and that's definitely idling correctly. Idle's a little bit low because it's cold. And the tach definitely reacts better. It was reading way off at higher RPM, way off. And the thing wouldn't come up more than about at that lower line at idle before. This is where it'll be when it's warmer. It'll be about right there. About 900, well, according to this. There we go. So we're all good here. And what I've done here is I back probed right at the yellow wire coming off the CDI for 1 and 3. It's the same wire. I don't need to be up here anymore, because part of that reason was to diagnose whether or not it was getting a good signal up front, which obviously it was. So now we can simulate the same thing with that signal source. Go back over here with the unit that came out of it. Whoops, I'm tripping all over everything. The instrument that came out of it, which is right here, and see what we got. Okay, let me turn on the DC power supply here. Whoops, try turning the switch on. I had the attenuation wrong on the probe here. Yeah, it doesn't matter. Shows you the signal either way. I could change the volts per division, but it doesn't matter. I hear it doing the same thing. I feel it rather. And that same little tickle thing. Why does it not want to go up where it's supposed to be, though? Now, I'll give you a shot of both of them. On the one on the left, the original tach, note how sluggish it is compared to the one I just put on the bike, the replacement tach. Well, it seems to be a little more accurate than I thought it was at higher RPM. When I did 3000, it was very close to that. But all right, so this is what I just did. I took the needle and just carefully flexed it so it's past the stop here. So this is in this particular position where the little worm gear is hitting the gear inside there behind here. This is the neutral position. And I wonder if that is how you set this up. Like, in other words, calibrate it. Because if you know, when you take, I didn't do anything on the other one, the one that went in there. I didn't touch that. I didn't do any adjustments or anything. I put the motor in that was there, and that's it. You know, the one I had originally came out of the display. Maybe we have to kind of calibrate this. Maybe we had to pull the needle off, just clock it and put it back on, so in this resting neutral position it's just resting up against that pin. I don't even know if that's possible to do without destroying the damn thing. Got a little tape here to protect the face, and it seems to be moving. Yeah, there it goes. Ah, okay. So all we did was really just pop the cover off of it. All right, so if you look down right there, let me try to level it out for you. There's like a knurl in there. Kind of hard to see because I can't get the thing to focus right. There it is. I got it now. You see the knurl? So that shaft is got a knurl machined into it or made into it, and then that thing pushes on there and holds it. I seriously doubt that's going to come off without destroying it. There is the point where the spring hooks in to the fixed part, which really isn't even fixed. It's actually part of that gear. So apparently the spring tension varies with the position of the gear. I think this answers that question we had before. The spring moves with the gear, therefore it's most likely a damper for the needle so it doesn't bounce around with the impulses that it's receiving from that computer. You know, there's no reference going back to any control as to where the motor is located. Like, in other words, it don't have no sensor in there I can think of. It's got a lot of wires, so this is really the $64,000 question. Why does it have so many wires? Why does it need so much if it just kind of pulses up or down or holds it in a certain spot? So I would suspect maybe there is some sort of a feedback mechanism. Maybe we need to take the motor apart and actually see that, because that'll help us understand what's going on. I mean, does it provide feedback to tell it where it's at? I don't see how it could, but if we take the motor out, and I noticed this the last time we worked on this, when there's no motor in there locking that gear in place, this just stays wherever it's at, which makes sense. That spring is attached to the gear. So when the gear turns, the spring is going to turn too, ergo it's not going to put any force on to push it to return the needle back to the stop here. Yeah, so that's pretty clever how they designed that. That spring clearly serves two purposes. Number one, it dampens the vibrations as described before from the pulses coming from the computer. Number two, it is a hard return as long as it's locked in between the drive worm and the driven gear. So that is pretty neat how they did it. And I'll be honest with you, this feels somewhat tight. I'm going to take some of this super slick stuff. It's like a citrus-based lubricant. I got it at Ace Hardware recently. It's actually quite good. And we'll we'll squirt it everywhere. Yeah, I have it in a syringe here and it decided to start squirting. Jeez, if I was that young. Okay, so we'll put a little bit on here. With no sense in putting it there. Let me see, where else can we put this? Oh no, it goes through that hub in the center, which looks all dirty too. So if we dribble a little bit into this hub here behind the spring. I think I got some in there. Oh yeah, that feels better. Could this simply be a matter of it binding up because it got goo in there? Maybe that's it. Maybe it just had some crap in there and... Oh, that's a lot easier. I can feel it. Oh yeah, that's really getting easy now. Supposedly, this stuff doesn't attract dirt and crap like oil does. That's why I got it. Use it on locks and things like that are outdoors, like padlocks. And it seems to be working really well. This is a lot better. We're going to put it back here and we'll shove our motor back in. Ah, button! Oh yeah, that's way high now. So it does have something to do with clocking it. Well, how the hell do you do that? This is what we'll do next. We will take that motor back out. So there's got to be some sort of a clocking procedure for it. There has to be. Otherwise it either reads low or reads high. I mean, I can turn it once I get it in here, but I don't think that's going to make any difference. Like, I didn't do that in the other one. You know, let's just do it this way. I'll just turn it down till it gets right down to the stop. Maybe that's what I did originally, you know, when I had the thing apart the first time. Rolled it back and forth until it sat against the thing. But I didn't do that. Whoa, putting the one in that's in the instruments right now, the one that works right. I didn't do that. I just shoved the freaking thing in, and did I get lucky or something? I don't know. I'm going through this only because I'm very curious as to where'd the other screw go. All right, I found it. It was like a mile away, of course. But now it rests right back down on the thing, but it would turn, of course, if we reached inside there and just turned that worm, it would move. So, I don't know. That's kind of weird, but maybe that's all the clocking procedure it needs. Just roll it back until it sits against the stop pin. I don't know, let's find out. That's a lot better. No, that's a lot better. Okay, it's better. We're on the right track. So I would say the problem is we just have a bad, display as far as the innards go. It may have been just because it's kind of gummed up or something, but it works better. Who knows? Vibration over the years. It's an interesting experiment nonetheless because, I verified, we had good signal on the oscilloscope. You need to check that. Check to see if that wire is going to ground in the manner like I did. Pull the tank, disconnect the coil, disconnect that plug, and just meter that wire. If it goes to ground at all, even any ground reference whatsoever, there's your problem, lady. I want to make sure there's no ground references because what took out the original 1 in 3 igniter, the spark box, whatever you want to call it. What took it out? The only difference between it and the 2 and 4, the 2 and 4's got the rev limiter built into it, as far as I understand, as far as that circuitry. The 2 and 4 CDI also triggers the fuel cut, which is the fuel pump relay. And I think that's why it's bigger. And then 1 and 3, the only thing it does differently besides fire the spark plug is, feed the signal for your tachometer. So yeah, it's one of these things where learn as you go. We got a successful repair by simply replacing it, which is really following the service manual. On the tachometer in particular, it says you check the wire that goes from, it says number 1 coil, but it's actually the 1 and 3. The wire's good and the tachometer isn't working, replace the tachometer unit. Duh. Anybody could do that, but I want to know why. I can't really say I know why, except for the fact that this is faulty for some reason or another. So yeah, kind of fun. Okay, so next morning, I was thinking last night that maybe we should test this a little further because I think there might be another way to see what's actually going on in this thing. Why don't we use the oscilloscope on this end of it? We've been testing on the input end and seeing the signal coming in off the coil, to trigger this device. After it processes through this quote-unquote computer, through these wires here, what does the signal look like? So we're going to go ahead and back probe these guys and see if we can figure out what the signal is. I'm set on the 5 volts for a 5 volt per division DC scale. I'm assuming there's going to be direct current coming out of here to power this thing. I don't know if that's the case or not. We can always change it to AC. And right now we're at 50 milliseconds per division. So I think that's where we were yesterday. Yeah, I have it hooked up basically the same as I did yesterday, except I'm going directly into the yellow wire here instead of going through the connector. It doesn't really matter, it's the same input. I don't really know if it means anything as far as the colors go because these colors may not be representative of anything typical to Honda. Now it stands to reason with that thing pulsing back and forth to hold a particular location. and also for it to go up and back down. I don't believe it goes back down just on that spring, that little clock spring alone. I think it actually gets directed back down by the motor, controlled by this device here. If that's the case, then I think it's reversing polarity. So I think maybe the red is a constant power, and you have two greens, which may be ground because there's two different sides to the polarity on this thing, and maybe the control is these three different wires here. The yellow, the white, and the blue. I don't know. That's what I want to try to figure out, because it would be nice to kind of wrap our heads around how this thing actually works. Well, she's stone cold and I didn't turn the enricher on. Let's see what the red wire produces. Well, it appears our tach wants to misbehave even more than it did before. That's an interesting pattern. It's like changing pulse widths. That's on the red wire. 50 volts for division. That's better. Let's go to the yellow wire. Pretty much the same. On the white wire, different. It has different lengths. You know, wider, shorter, wider, shorter, much wider, much shorter. The blue wire, I don't think we'll get anything on the green. No, these are probably grounds. Actually, it's coming up at a voltage. Maybe that's the hot. Maybe the greens are the hot. I'm in the red wire. Let's rev it a little bit and see what it does. I'd like to reiterate, I have no idea what I'm looking at here, but I'm learning as I go. Now, when you're learning EKGs in the medical field, you kind of look at the base waveforms of a particular rhythm in a textbook, and you learn how that looks in typical form, and then you apply it to a clinical situation. So that's kind of what I'm doing here. So I'll repeat this clip here and say that this clearly looks like a rectangular wave as I looked it up online as far as the typical oscilloscope waves look, which is a presentation you see in processors and computers, which kind of makes sense depending upon the definition of this little module they say is a computer. So you can see the waves differ in width depending on the RPM. So when I gun it up here and get the RPMs up, you can see those rectangular waves get really tighter just right there. And then when it levels out, it assumes that wider pattern again. And then when it comes back down, it does the same thing. So that really kind of makes sense that when it's stable at a certain RPM, the waveforms are pretty much the same. But when it changes, that width either gets tighter or otherwise accelerates, and it brings the tachometer needle up or down. So it's pretty interesting. And like I said, I don't know what I'm looking at, but I'm learning as I go here. That's a little better representation. I don't know what those peaked spikes are. I thought it might be some artifact or noise, but I looked it up in a rectangular wave. There's a couple of articles on it I read that this might be an induction spike, and it's just a phenomenon of how the thing is being probed as far as, you know, errors in the probing, or it just could be, again, induction because it is an electric motor after all. So who knows? But it is interesting to see that, but it's something I really don't pay a lot of attention to because I don't know what it is anyway. It's very interesting. So when I have both channels hooked up here, it's pretty interesting. you can see the difference in the patterns, and I'm just kind of going random wires here. I don't know which is which. But in this particular case, I'm wondering if one of these wires that I'm tapping into versus the other, the yellow versus the blue channel, is actually a feedback back to that little processor, which would make a lot of sense to tell it actually where it is. So, you know, that kind of makes sense because I don't know which wires are which, but how else would this thing know where that needle is? Because there's no hard stop in the needle itself. So maybe it's reading the feedback on some of these wires back at the processor, expecting a certain result based on what it's sending to the gauge itself, to the meter. And so once it comes back, it says, okay, I know where I'm at. Well, that was a cool experiment. I kind of like doing it with 2 channels and see what kind of results we were getting. Most of the times you could see in there, this thing was pretty much, you know, different as far as the 2 channels go. The way I had probed channel 2 was the red wire. I just left it there. It's very difficult to probe these things and actually move things around, but it still brings us back to the same starting point or ending point, as the case may be, that although we did get it to work a little bit better, whoops, got the dropsies today, by lubricating this thing up, it's still not quite as good as the one we put in there. And we know all this stuff works because it worked perfectly with the one that's in the instrument cluster now, the one that came out of here. So it's just one of these things like what the service manual says. If everything else is good, then simply replace the tachometer. Or if it was the speedometer, it would be the other side of it. So yeah, I don't know the engineering, and I'm not familiar with this stuff enough to even extrapolate really what this means. All I can look at is, you know, from a logical point of view, we have different timing as far as those pulses go, those square waves, which obviously represent some sort of a voltage pulse that goes into this to control it. And because of the different timings, that kind of explains this thing doing its back and forth to meter this, to throttle this would be a better description, I think, to throttle this and control it into a certain place depending on what the signal coming in from the CDI is telling this thing to do. So that sounds reasonable to me, but again, I'm not terribly knowledgeable or educated on this stuff, but it was a fun experiment, like I said. Net sum, this is bad, the other one's good. We've solved it, but now we know a lot more about it, and I think that might help us in the future. Hopefully it helps you all too. All right, so that's going to be it. I hope you got something out of it and enjoyed it. I had a lot of fun doing this, actually, especially when I have a successful end, because I can't stand it when I'm like scratching my head and scratching my butt at the end of the day, still trying to figure out what the problem is. We got something that works, and that's all I care about at this point. But I also care that this hopefully will help somebody. Even if 3.2765% of my viewers actually watch it, maybe 2 years down the line, somebody will see it and go, bing, and a light bulb will go on, and they'll be able to fix something based on the information contained herein. So with that, we'll close it out. I'm going to be doing another video on my lathe. The 4-jaw chuck has got a big-time balance problem. And I mean when you have a piece of stock dead nuts indicated into the center of that chuck, anything over about 600 RPM, it'll shake the living dog you-know-what out of that lathe and just start vibrating everything. The chuck is way out of balance. And so we're going to figure out a way to check that balance. Thanks for watching. Always remember, don't just repair, restore. We'll see you on the next video.